Okay, today the lesson is about probability, but specifically about rearranging things. You've been using the word combinations wrong in a million different ways. I'll give you an example. Let's say that I took all of you guys in this room, and I'm just going to say for today, there looks like there's about 25 of you. Okay, and if 25 of us were to go out and in the parking lot's right out there, and there's a bus out there, okay, and we go jump on the bus. And let's say that we take a bus that happens to have 25 seats, just to keep it simple, because we don't need this to be more complicated than it really is. Let's say there's a bus with 25 seats out there, and we all jump on the bus, okay, fill up every seat. Then, if I have you rearrange, that's not a different combination, that's called something else. If you rearrange, as in change it at all, it could be like 5 people switch, it could be just 2 people switch, then that's a different what? Permutation. Very good. That's a different permutation. So here's my question. With those 25 of you going out on the bus and all the different permutations, you used to say combinations, okay? All the different permutations, there'd be a lot of them, okay? If we took 1 second, just 1 second to rearrange, like, okay, 1 second, that's really quick. But 1 second and just even 2 people move, and then you got a new combination. Oh, not a combination. What it's called? Permutation. Okay, we got a new permutation then. If we could switch as fast as 1 second, do you think that's realistic to shuffle a lot of different people in 1 second? No. How about in 1 minute? Do you think we could, even that would be a little bit of a stretch, but do you think in 1 minute we could have a significant reshuffle of the people on the bus? Okay, all right. Then if it takes us 1 minute to reshuffle, how long do you think it would take at 1 minute per reshuffle before we have tried out every possible permutation? Please don't use math exactly. I don't want you to use a calculator at this point. I want you to have your best guess. How long is your gut feeling like an hour, 2 hours, 5 hours, 24 hours, 3 days? Okay, figure out what's your best guess on how long it would take us to try every possible permutation of the 25 kids in the spot on the bus. How many? You can do it in hours or days, would be fine with me. How many hours or how many days do you think it would take? I'm going to pause for a second. Okay, so we have multiplied out 25 factorial here. 25 choices for that first spot on the bus, 24 times 23 times 22, and that's called 25 factorial, and I showed the kids how to do it on a calculator. It's under math, PRB. I'll just type it in one more time for the calculator people, 25, and hold on a second, I have a marker missing. Okay, this is becoming a train wreck, pausing for, okay, 25, and then I go to the math, PRB, probability. Sorry, those of you that are in the classroom right now, but I'm almost done. And then I'm arrowing down to the exclamation mark and showing people where I got this monstrous number. 25 factorial is that, which we then wrote out as that. And holy Moses, that's how many different, not combinations, what are they called again? Permutations that there are. And that's with only 25. Would you agree that a deck of cards is similar to a group of people? Okay, they're all different, aren't they? I mean, there's no cards that are exactly the same. You have 2 aces, but they're different kinds of aces, right? So they're all different. So imagine for a moment a shuffled deck of cards. Do you get the idea that that would actually be a heck of a lot more than this? This is only 25 getting shuffled, so to speak. I know you don't shuffle people, but so 52 factorial is how many it would be for a deck of cards. What that means is, I think that this might blow your mind. It did for me. Your mind's already exploded? All right. If I grab my deck of cards here, I'm going to pause for a second while I do that. So on my deck of cards that I have in front of me and I just shuffled, this arrangement of the deck of cards has never been seen before in the history of mankind. You're thinking, no way. No way. There's been so many people have shuffled so many decks of cards. There's no way that that exact shuffle is unique in the history of time, and it absolutely is. And you're going to be like, well, prove it. Okay, here's proof. If you took 6 billion people, which is close to the whole world's population, and you had them shuffle cards where cards are pretty quick to shuffle. You could shuffle a new shuffle every 1 second. If, since cards were invented, they have been shuffled by 6 billion people once per second ever since, they still wouldn't have shuffled every shuffle that's possible. If, since the beginning of the invention of cards, everybody in the world was only shuffling, sounds a little bit like that every day they're shuffling. Anyway, that's a different thing, though. Anyway, if this deck of cards were shuffled enough times so that, you know, like you'd probably likely have the same combination, you would not assume that I just shuffled a new one in the history of time, would you? I mean, it just doesn't seem possible. But that's what, these just blow your mind. Remember, this number on the board, that's not how many different decks there are. That was if there was only 25 cards. Do you get that every time we go up another card, it exponentially gets bigger? So would you please put in 52 factorial on your calculator? Okay, we got 8.06 times 10 to the what? Times 10 to the 67th. That means I have to move the decimal over 67 spots. That's how many decks of cards there are. And if you want to figure out how many shuffles we could have had, we'd have to figure out how many years has it been that cards have even been invented, and then take 6 billion people at a time, every second, shuffling, and we won't even be close to half. We won't even be a third of the way to how big that number is. It's just insanely big. And you know something cooler than that? There's more stars than that. It's a lot of stars. And then here's something that might even blow your mind further. Almost all of those stars have planets going around them. So you take an average of, let's say, 4 planets. That's even probably on the small side. Times, there's way more stars than that. Holy crap, you get into some big numbers. You see why scientists use scientific notation? They don't want to drag around 67 zeros. All right, so I thought that was really cool to find out that if you shuffle a new shuffle, that you just made something that's never been seen before. Is it possible that 2 people could have the same shuffle? Yes. But it's probably more than 99.99% sure that the shuffle you have has never been seen before. The only exception to that would be when the deck is arranged at the beginning. You know what I mean? When they come to you in a box, you get that they're usually in order, with all the hearts and then all the clubs and then all the spades and then all the diamonds, and they're in order. That's the one exception. All right. So, I thought you'd like that one. That is in the context of permutations. Now, I want you to be able to see this from a slightly different perspective. I'm going to have 4 things on my desk up here. Phone, calculator, remote, and cards is a plural thing, so I'm going to use stapler. All right? Phone, calculator, remote, stapler. I got these 4 things. Now, if I said you can pick out any 2 of them randomly, would you go pick out 2 of them? Just come on up and grab 2 random ones. I don't know which ones he's going to take, and pull them forward out of the 4 things. I knew you were going to take those 2. All right, anyway. So he pulled forward the calculator and the remote. Okay. How many different things could he have pulled out? That question is this. 4 4C2. Everybody write that down. I know you don't know what C stands for yet, but C stands for combination. Take a wild guess what P is going to stand for. Permutation. Combination means when he pulled out these two, do you get, I don't care if he rearranged them, they would still be the same two. The order didn't matter. That's a combination if the order doesn't matter. When you're shuffling like a deck of cards, the whole point is that the order is different and therefore the order matters. But in a problem like this, he could have pulled these two out, and I don't care if he left them this way or this way. It doesn't matter. The order doesn't matter. So this is a C question. 4C2. Let me show you how to do it in the calculator. You ready? Type in the 4. And then there's two ways to get to this. Yes, it's still on that same menu from before. But in case you forget, I want you to remember the most powerful button of them all. 4, and then what's the most powerful button of them all? The catalog. Do you see it right above 0? I want to be the first person to show it to you. Most kids don't even know it's there. It's the catalog button. And now, where is it? Well, you have to know its real name, which is NCR. I know, and this one's kind of lame because you wouldn't have known it was NCR. But if it's something like absolute value, it's got a name that's really obvious, ABS. Or if it's GCF, take a wild guess what it's under. GCD, actually, because factor and divisor mean the same thing. LCM is actually LCM. But anyway, this one is called NCR. So we got to find that. And yes, there's another way. It's under math and probability, but I wanted to show you this way. And now how do I find N quickly? This is an alpha mode, so it automatically knows to look for a letter. The next thing I hit will be a letter. And I want to find the N. There it is. And now do you see NCR? Ooh, there it is. And I hit enter. And now it's already got the 4 filled in, 4C. And for you, those of you that have an older calculator, you're just going to say 4, and then it'll say NCR. And then you can say the other number, 2. So for some of you, this might look 4C2. For some of you, it might look 4NCR2. Either way, you're going to get the same answer out, which was 6. That means there's 6 things that he could have pulled out. When I asked him to come up and take 2, there were 6 different things he could have done. Doesn't seem like there should be 6, does it? Even the combinations number is a surprisingly large number. Could have been those 2, could have been these 2. That's 2 of the combinations. Why aren't they called permutations? Because I don't care if it's phone stapler or stapler phone. I don't care. If I don't care about the order, it's a C problem. All right, back to if I asked him to pull out any 3, what do you think the question would change to now? 4C3. Everybody see how fast you are. 4C3. I'm going to do it the faster way. I'm going to go through the math button. And it's under probability. And you guys are going to be faster than me. I'm old, so it's 4. Does it make sense that there's less that you could pull from? If you have to take 3 of them, you're taking almost all of them right off the bat, right? Okay. So there was, if I choose 3 at a time, there were 4 different ways to do that. All right, last is, what if the order does matter? And it wouldn't be 4C3, it would be 4P3. I got 4 things, he's going to pull out 3. Here, I'll slide him closer to you. Can you reach him? Pick 3. Oh, I thought you were going to go with different ones, so I was wrong. All right, now these 3 that he's got picked out, the order actually matters. Since the order actually matters, it's a P question, 4P3. Should it be bigger or smaller? If the order matters, those are big answers. Remember the bus? Remember you on the bus? That was a huge answer. That was a P because the order mattered. What order you were on the bus was the whole point. P's are big answers. So this will be a big answer. Why? Because He could have pulled them out this way. He could have rearranged it that way. He could have put it this way. He could have put it over this way. He could have also put it this way. And there's so many different ways he could have done it. How many different ways? Well, 4p3. Somebody must be done with this in the calculator by now. What is 4p3? 24. Excellent. Now, you also have to be able to do them by hand. Do you remember the test on matrices where you had to sometimes do it by hand? In fact, we had a ton of them where you had a calculator allowed, but you couldn't actually use it because there was a variable in the middle of it. Watch how to do it by hand. You ready? 4 factorial. Remember what that means? 4 times 3 times 2 times 1. Over, you want to write this. Don't slip out off on me here. Some people aren't writing. You got to write this down. This is a formula you're going to have to learn how to do. 4 factorial. I know you're thinking, I'll just use the calculator. Not if we say it's RPG. Not rocket propelled grenade, no. But it could be variables here, and you'd still have to know what to write. All right, so 4 factorial over, I wish it was as simple as just 3 factorial. It's not. It's 4 factorial over 4 minus 3 factorial. What is 4 minus 3? 1. So it's 1 factorial. What's that? It's just 1. So it's really just 4 factorial. One thing I want to get across to you is that the P's and blanks will get you the same thing. Watch what I do with blanks. This one, 4, 3, 2, 1. Guess what? 24, just like your calculator said. But watch how I could have done with blanks. Those 4 things represent, sorry, wait, I pulled out 3 things, not 4. Those 3 things represent how many choices did I have for the first thing I pulled out. There were 4 things on my table here. How many choices did I have for these 4 things? I had 4. How about for the next one I pulled out? How about for the next one I pull out? Do you get that that's going to equal 24 also? You could just multiply your choices together. And the reason that the blanks work better than the calculator is that you can't do this. Well, some of you might be able to figure it out. You guys are really smart, so I don't want to challenge you to. Well, actually, I'd love it if somebody'd show me, but I think it's going to be really complicated and not worth it. Imagine for a moment that we have 10 kids that are going to play baseball, and we're going to put them in a batting order. But we don't want to just do 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. Why not? Well, that is how many different batting orders you could have. But when we put conditions on it, do you remember conditional probability? What if I say, we got one kid in here who is the bomb at baseball, like the best. Okay, is that you, Mr. G? Okay, so he at least likes baseball. I'll give him that. Okay, I don't have any idea if he's really good at it. Maybe he is. But let's say he is the best one in here. Where would you want to put him in the batting order? If you really know baseball, you know that there's probably a few different spots you could pick from. Give me an argument, yes. For which spot? All right. What do they call that spot? The cleanup hitter. All right. Because why? Because if you have him lead off, when he gets a hit, he can't really get anybody home. You know what I mean? But if you have somebody on base and then he gets a hit, you might get somebody home. Okay, so anyway, the 4th spot is a really good spot to have a good batter. So do you get, I have blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you know what? We got one really good kid. Let's put him here. I only have one choice for that spot. It's going to be Will. Let's say that there's, and if you're really good at baseball, you'd understand this too. There are certain people that are good leadoff hitters. What would make a good leadoff hitter? Anybody that knows baseball, can you tell me? Yes. All right. Why do you want a fast person out there? Yeah, so if somebody gets a hit, they can make it from first to third base maybe instead of just first to second. So if somebody's really fast, let's say we have 3 really fast people that can also hit decently, then I only have 3 choices for this spot for my leadoff hitter. And then maybe we want to put the other 2 here. Now I have two choices for this spot. These are the fast people. And then one choice left. It's kind of like our best hitter overall or our strongest hitter, maybe the one that hits the most home runs, goes there. And then these three people, we'll just keep it simple. They're fast people. We could make this super complicated if we wanted to. But wait a minute. How many people have we used up, so to speak, out of our 10? 4 are used up. So how many choices do I have for this spot? 6, and then 5, and then 4, 3, 2, 1. Do you get how that would be very hard to try to represent in a 4P3 kind of problem? The blanks thing, really, really handy for conditional. I'll give you another example that's kind of like that. Maybe you're not into the sports thing, but many people get married, so you might be able to relate to this. You've probably seen pictures of the bride and the groom. And let's say there's the bride and the groom, and then they're going to have the mom and dad from each side. Okay, so then you got bride, groom, and 2 sets of parents. Do you get that's a total of 6 people? You would not just do this like this. 6, 5, 4, 3, 2, 1, because that means that people could be completely random. You ever seen wedding pictures where it's completely random? It's not likely. Do you agree that the wedding planner or whoever's in charge of pictures might say, okay, we want the bride and the groom in the middle of the picture? Does that make sense? Then how would you do it? I'm going to pause for a second while you try to figure it out. Remember, there's one bride and one groom. And we don't care if it's bride first and then groom or groom first and then bride. Do you get these are the 2 key spots? How many choices do you have for the first spot? 2. Second spot? How many people left over here? 4, 3, 2, 1. Does that make sense to you? There was a bride and a groom, or we only had 2 choices for that middle spot. Okay. I'll give you one last one that's kind of like that. Let's say that it's just the bride and her bridesmaids. So let's say there's a total of 7 humans there, the bride and 6 bridesmaids. And there's 6, so it's kind of tough to put the bride in the middle of 6, you know what I'm saying? So let's say you got 2 choices. She can either be on the left end, or she can be on the right end. 7 humans. Or did I say 7 or you're 6 humans? Okay, then there is a middle spot. We could do it that way. Let's just do it that way first. That's the simplest thing. If there's 7 people, put the bride in the middle. Tell me how many different ways you could do it. Did you just make 7 blanks? And there is a middle blank because I made 7. I was trying to make it so there wasn't a middle, but I goofed. So that's the middle spot. So there's only one choice. It's got to be the bride. And then why isn't there 7 down here? There's only 6 people left, so it's got to be 6, 5, 4, 3, 2, 1. It's all multiply. You multiply your choices. Make sense? Okay, now I'm going to change the question to bride and her 3 best friends. Get it? 4 humans. Bride, 3 best friends. Can't put the bride in the middle, can ya? Not the country. Can you? All right, so 4 spots. Where would you put the bride? On the ends? One end or the other end? Oh, I said or. What does or mean? It's either you put the bride on this end, you only have one choice, the bride goes there, and then you got 3, 2, 1, or, and I know this is going to look very similar, there's only one choice for the bride on this end, and then it's, and I get that they're equal numbers, but since it's an or, what do? Add. You have 3 times 2 is 6 on the top. 6 ways that way you have the bride on the right, or the left, doesn't matter. And 6 ways where she's on the other end. Makes a total of what? 12 total ways you could take that picture. There, you've learned everything that you need to know about permutations. That was a lot, I know. I warned you, this chapter is not as easy as the last couple chapters. That's one of the reasons I was really happy to see a couple A's go in the grade book. So if you end up with a B for this one or whatever. Oh, by the way, I haven't I talked about this much, but we're going to do retakes differently for this. If I haven't already told you, did I already tell you this? You can retake individual tests for the next next two tests. So in other words, if you bombed the last test, you can take it over again. You're not going to get the same version, you can get a different version, but you don't have to wait until the cumulative. Okay, so this test that's about to come up too, it's the worst way ever. It's to plan on failing the test and I'll just take it over again. You're adding guaranteed 1 extra day to come in for corrections and another extra day to take the test. It's adding 2 days. It'd be a lot smarter to just learn it the first time. All right, so let's go look at the homework. I'm going to pause for a second and we'll pull that up. So here we go. You are going to do, we're going to cut off a big chunk. It is. So we're cutting off problems 4 and 5, which does cut off quite a few parts. That's cutting off like 10 questions. Okay, part A. How many ways can the 8 books be arranged on the shelf? A lot of people are like, well, you put them on the shelf and you're done. One way. Now, that's if the order doesn't matter. That would be a combination. This is a permutation. Could you do it with blanks? Yes. Could you do it with 8 choosing a permutation of 8? Yes, 8p8 would do it. Or blanks. Guess what that would be? 8 factorial over 8 minus 8, which is 0 factorial. By the way, that is defined as 1. If you ever hit 0 factorial, it means 1. You can check it on the calculator if you don't believe me. 0 factorial is 1. So then that means 8 factorial, which means you could have done it with blanks, which would have been 8 choices for the first book. 7, 6, 5, 4, 3, 2, 1. I know it's a big number. Multiply it in any way you want to on the calculator. The fastest is probably 8 with a factorial button. And on these answers, it's okay if you want to write them as times 10 to the whatever. I'm okay. Don't do this, though. 2.15 EE6, because that means you don't really know what that means. Even if it just said E6, you shouldn't have an E6 there. You should say times 10 to the 6th. All right. Okay. I'm just going to pause for a second to clean this up. Okay. So, 8 factorial. How many ways can they be in? So volume 5 would be the rightmost book. 1, 2, 3, 4, 5, 6, 7, 8 blanks. That one's got to be volume 5. Don't put 5 choices. There's only one volume 5. 1. And now I think you're thinking, well, there's going to be a 1 at the end anyway. But don't do it that way. Think 1 choice for that. How many choices for this? 7, 6, 5, 4, 3, 2, 1. Do you get how that is different than 8 factorial? Still a pretty big number. And then all of a sudden, it whips out the word probability. That's the first time we've had this all day. Up until now, we were saying how many different combinations there are. Do you get, if you were to have guessed on the bus question, like what order everybody would have sat in on the bus, that would have been a 1 in 15, not quintillion even. It was like septillion. There's no way you would have guessed what spot everybody's in. There's just no way. It's kind of like, have you guys heard about this? The March Madness brackets? If you fill out a bracket, there's almost no way to pick the perfect bracket. Warren Buffett has gone so far as to offer like $1 million challenge if anybody can pick the perfect bracket. He'll give them that. But he's not worried because like nobody's going to ever do it. Because it's a 1 in 4 quintillion or something like that. So, okay. I think he only offered that, by the way, to the employees of his company. Just to keep, you know, like, what if some guy in wherever, Timbuktu is actually a place, wants to, like, you know, challenge him. He's not going to go through that. So he did that with just his employees. All right. Probability means what you want over what's possible. What do I want? I want the volume 5 as the rightmost book. That's this. That's what I want. Over means divided by what was possible. All of those, which is what was possible. You're going to divide them. I would use scientific notation, and I would use the second answer thing on the calculator to do it. But option B, watch this. 7, 6, 5, 4, 3, 2, 1. 12-minute warning. And 8, 7, 6, 5, 4, 3, 2, 1. Wait. Cancel, cancel. 1/8. You see how cool that was? If you write them as factored, because if you can factor it, you should. And then you see how it just all cancels. There's no 1? Well, we could put 1 at the beginning. If you cancel everything, there's a 1 left. Okay. So, I think you've got the idea. I recommend using blanks whenever there's some conditions on it. If it has to be increasing from left to right, then I would want to have conditions, so I'd want to have blanks. The blank way is probably the best. And if it's super simple, do it some other way. But if it's complicated, use blanks. All right. That's all I got for you for today.